In this video, we're going to do more examples from the section on more algebraic equations. One example is going to be where we solve an equation that has two different square root expressions in it. And another example will have an equation with a fraction exponent where there is no plus or minus in the solution. In this example, we're going to solve an equation that has two radicals in it. The square root of x plus 7 plus the square root of x minus 9 equals 8. To solve such an equation, your first step is to get one radical all by itself and then square both sides to get rid of that one radical. So that's what we do. We subtract the square root of x minus 9 from both sides and get the square root of x plus 7 by itself. Then we square both sides and make sure to quantity square the right side. The left side just turns into x plus 7 because when you square a square root, it cancels out the square root. On the right side, we have to FOIL out 8 minus the square root of x minus 9 times 8 minus the square root of x minus 9. So when you do that, you get 64 minus 8 square roots of x minus 9 minus another 8 square roots of x minus 9 plus the square root of x minus 9 quantity squared. When we multiply a negative times a negative, it turns to a positive result. And then we simplify to 64 minus 16 square roots of x minus 9 plus when you square that square root of x minus 9, you get an x minus 9 added on at the end here. And now we combine like terms. 64 minus 9 gives us 55. And then we have our plus x. But then we subtract x from both sides, and look what happens. The x's cancel out, and this leaves us a simplified equation of 7 equals 55 minus 16 times the square root of x minus 9. So now we only have one square root left. We have to isolate that square root. And we do that by subtracting 55 from both sides. 7 minus 55 is negative 48. And we have that equal to negative 16 square roots of x minus 9. To get that square root all by itself, we divide both sides by negative 16. And negative 48 divided by negative 16 is just 3, so our real simple equation is 3 equal the square root of x minus 9. Now we just square both sides to get rid of the radical. And this gives us 3 squared equals x minus 9. Add 9 to both sides and we get an answer of x equal 18. But we're not done yet, because all radical equations require that you check the answer. Oftentimes you get extra answers that are not correct. So we plug in 18 for x in the original equation and we get the square root of 18 plus 7 plus the square root of 18 minus 9 equals 8. And that simplifies to the square root of 25 plus the square root of 9 equals 8, and that checks out because we get 5 plus 3 equals 8. So x equal 18 is our solution. In this next example, we're going to solve an equation that has a rational exponent with an odd numerator. 4x to the 3/4 power minus 29 equals 79. To solve this type of equation, our first step is to get that x to the power all by itself. We start by adding 29 to both sides of this equation. This gives us 4x to the 3/4 power equals 108. We still don't have x by itself. We have to get rid of the 4. We do that by dividing both sides by 4. And when we divide the left side by 4, the 4's cancel. On the right side, 108 divided by 4 gives us 27. So our simplified equation is x to the 3/4 power equals 27. Now to solve this, we take the 4/3 power of both sides. When we do that, the left side just turns into x because you multiply 3/4 times 4/3 and the exponents cancel each other. On the right side, we get 27 to the 4/3, or x equals the cube root of 27 to the 4th. And you might be wondering, why no plus or minus? Well, because in this case, our original equation was 4x to the 3/4, and our exponent was 3/4. It had a numerator that was odd. So in our equation, we're taking the third power of a fourth root, And that has the same characteristics as a third degree equation. And when you solve a third power equation, you do not get a plus or minus. Only when you're solving a squared equation or a fourth power equation do you have a plus or minus. So when the numerator is even, use the plus or minus. When the numerator is odd, do not use the plus or minus. So now we can evaluate this radical. And the cube root of 27 is 3. 3 to the 4th is 81. We get x equal 81, but we have to check this answer. We do so by plugging 81 into the original equation. The 3/4 power is the 4th root of 81 cubed, which is going to be 3 cubed. And we multiply 4 times 3 cubed, subtract 29, and that gives us 108 minus 29, which is indeed 79. So 81 is our solution.